In this class, let us solve one more problem, that is structure of atom, right? So here you can see the question is the number of electrons which will weigh 1 gram is, right? So what we know, one electron weight is 9.1 into 10 to the power minus 31 kg, but in question it is in terms of gram, so let me write it as 9.1 into 10 to the power minus 28 gram, because 1 kg is equal to 1000 gram, right? So what I'll do, so 1 electron means it weighs 9.1 into 10 to the power minus 28 gram. If I have 1 gram, how many number of electrons are there? So that is what we want to calculate. Therefore n is nothing but 1 gram divided by 9.1 into 10 to the power minus 28, which I can write it like 10 to the power 28 divided by 9.1, which is nothing but 10 divided by 9.1 into 10 to the power 27. So I'll get something, say 1.098 into 10 to the power 27 number of electrons. So that is what they are asking. So answer for this question is nothing but the first option. The number of electrons are this much in 1 gram. So if we talk about the second question of the same, so here you can see that the question is the certain metal when irradiated by light, they have given the frequency in hertz, emits photoelectrons with twice of kinetic energy, right? So if I supply this frequency, let me call it as frequency 1, so it will emit a photoelectron of twice kinetic energy. Twice kinetic energy as did photoelectron when the same metal is irradiated by this frequency. Let me call the second frequency as mu2. When mu2 frequency of light is supplied to a metal, it will irradiate or it will emit a electron whose kinetic energy is simple kinetic energy, right? Ke. So if for this frequency, if it emits Ke, for frequency mu1 it is emitting 2 kinetic energy. And the question what they are asking is the threshold frequency of the metal is. They are asking threshold frequency of the metal. So what we know, so this is photoelectric effect. So here we know the electrons on the surface of metal, when we irradiate frequency, something frequency from the sun, this electron comes out. This coming out electron we call it as photoelectron, right? So when we apply mu2 frequency, it is coming out and this is going with kinetic energy Ke. When I apply frequency of mu1, this electron is going out with kinetic energy 2 times of kinetic energy, right? So what is the minimum frequency of this electron? The question is. To solve this, what we know this equation. Total energy supplied is nothing but work function of metal plus kinetic energy, right? So using that, I will do these equations. So for mu2, the kinetic energy is Ke. So mu2 means nothing but E2 is equal to E0. For same metal, the work function will remain same, but it varies with metals, that we know, plus kinetic energy. So and they are asking E1 for mu1 it is E1, that is nothing but E0 plus 2 times of kinetic energy. So what I will do, I will arrange this like kinetic energy is nothing but E2 minus E0. So E2 is nothing but H mu 0. So E0 is nothing but E2 is nothing but H mu 2 and E0 is nothing but H mu 0, because we know E is equal to H mu, right? So using that I wrote. So this kinetic energy, what I got here, I'll substitute it here. So what I'll get, so E1 is nothing but E0 plus 2 times of H mu 2 minus H mu 0, right? So here E1 can be written as H mu 1, E0 can be written as H mu 0 plus 2H mu 2 minus 2H mu 0, right? So if I simplify, so H I can divide everywhere because H is common here, left and right. So mu 1 is equal to mu 0 minus 2 mu 0. So it will be 2 mu 2 minus mu 0. The question is to calculate mu 0 only. So let me take it here. So if I take it here, it will become plus mu naught, which is nothing but 2 mu 2 minus mu 1. So frequency they have given. So here I had mentioned this is mu 2, which is 2 into 10 to the power 16, and this is mu 1, 3.2 into 10 to the power 16, right? So mu 2. So 2 into 10 to the power 16 hertz minus mu naught is 3.2, right? It was something 3.2. Yes, mu 1 is 3.2 into 10 to the power 16 hertz. So I want mu naught. So can I? Yes, 10 to the power 16, 10 to the power 16 hertz is common. So 4 minus 3.2 into 10 to the power 16 hertz, which is nothing but 0.8 into 10 to the power 16 hertz. If in answer, if they had given, it is 7 into 10 to the power 15 hertz. So based on options, we will select the answer, right? So the answer should be 8 into 10 to the power 15 is there. No, yeah, 8 into, sorry, why I have written 7 here? It should be 8 into 10 to the power 15. So the answer for this question is second option.